Well,
once again to both of you. Yeah.
Well, thank you. It's a pleasure to be here. And we thank all of you illustrious experts who are doing work in India, which is undergoing some really challenging times today. And we look forward to your comments on Didi's work. And Didi, just before we start, I wanted you to be aware that this group, the World Water Action Forum, has actually started movements across 5 major cities in India, reaching more than 25, 30 million through these major urban hubs, but they also have hooks into rural areas. And you'll hear from, I think Chandra's here today and some others who understand the village issues, but most of them are really fascinated with the and engaged with rebuilding soil and understanding the need for soil. But the total water cycle, which you talk about, is also a focus for them. And they are working on a program and now impacting 40 different schools across India with a goal of impacting 50 this year. And I'll just share a very brief video because I think it's so encouraging. To see the impact that they are having.
We have 34 million liters of water thanks to one initiative. Fast depleting borewells have severely affected the BBMP schools in the city. To tackle this, environmentalist Dr. Hariharan Chandrasekhar began the Rain Reach program for school-going children to educate them about water conservation so that saving water becomes a habit early on. The program sets up systems in municipal schools to harvest rainwater, treat sewage, and reuse both rain and wastewater. Furthermore, rain gauge weather stations and digital meters are also installed to help students measure rainfall. Every month, experts educate children about water conservation, teaching them how to take care of the systems, encouraging them to pledge to conserve water. With the city currently wasting nearly 90% of the rainwater that it receives every year, don't you think that such measures should be implemented everywhere? 40 schools in Bengaluru.
Sorry about that, but it's a beautiful movement. I'll put in the chat the way that you can donate if you're in the US or outside of India, but also we'll include the Alltech Foundation place for donations because every one of us can have an impact. And as you heard, Didi, and we know in the United States, people aren't as sensitive to the water movement everywhere, which you're going to be discussing. And if we were great stewards and understood how the water cycle does provide for us to meet needs, if we plan ahead and implement systems like the Rain Reach program, we can create resilience around the globe. And that's the purpose of Global Waterworks and the reason why we connect with the World Water Action Forum. And so it's a pleasure to be here, a pleasure to introduce you. I put your background in the chat and people can read about it, but I don't want to delay in having you just hear directly from Didi, who has also provided some curricula that I'll put in the chat. So, Didi, just thank you for bringing your knowledge, your international travels, and your expertise to the WOW group. We look forward to a lively discussion after you share sort of the background and the lessons that you've sort of curated from around the globe and added your insights to. So welcome, Didi.
Thank you so much. I'm really pleased to be here, especially today, as Mary and others know, we're in the middle of a big storm and a power outage. And I tried to go down to my office to get internet and there was a tree across the road. So I'm at a very kind neighbor's house who has a generator and using the internet here. And it's just a reminder that we really do all have to, our relationships come first, that we're not going to solve any of this without having friends and neighbors and being neighborly. So and I'm very impressed just to hear about all of the amazing work that people here are doing, and very excited to be with you and to be able to share some time. I have done some work in India in Andhra Pradesh with the Andhra Pradesh Community Managed Natural Farming Initiative. I've been over there in 2019 and to work with them with their master trainers. And currently we're about to publish the UN FAO Farmer Field School Guide Life, Land, and Water that I've written up for that project. So some of what you're hearing today will be in that manual. And Mary, I think, is going to post the current manual that was made back in 2016 or so. Okay, so let me bring up a PowerPoint. It's going to be a little bit because of the lack of internet. I apologize, it's not quite as prepared as I usually do in terms of slides, but we will make it work. So the first thing I usually do is to ask people, what are some of the things that you are concerned about climate change and about water in general? And you could put those in the chat. And you know, we know that water shortages is one, but there are a lot of other issues, right? There are heat waves and storms, and et cetera. So and so we end up, I'll just say a few that I can think of easily. We end up with flooding and we end up with drought, often at the same areas at similar times, which doesn't really make sense. We end up with very erratic rainfall, bigger storms on the coasts. The rain is not spread out very easily, so more extreme weather, yes. Terrible heat waves that we're having across the globe, even in places that we think of as very cool and pleasant. Ocean rise, conflicts over shrinking livable landscapes, right? Algae blooms, yes, absolutely. So, so the question is, how can this funny thing here on the screen, how can this address pretty much all of our concerns about climate change, about the environment, et cetera? And this is what I call the soil sponge, or my colleague Walter Jena, who also is doing some work in India, and who I learned with. We learned from each other over many years. He calls the soil carbon sponge. I've taken to just calling it the soil sponge because it's really about water, even though a lot of it is made of carbon. But all of life is made of carbon. You and I are made of carbon as well. So, and the soil sponge is the structural and functional integrity of healthy soil. And you can see here that it's made up of little particles of sand, silt, and clay, just broken down rocks. And then there are some plant roots and root hairs. And the plants feed some of the sugars that they make through photosynthesis to the bacteria and fungi underground. And those, as they're moving through and doing their work, they're exuding slimes and glues that hold these little particles together into aggregates. And when you aggregate something, like if we were all to aggregate in one room, you create space around it, right? So these all start clumping together and suddenly there's space. Just like if we all clump together, there'd be space around us. And then these fungal hyphae and plant root hairs act as strings that tie the aggregates together into something that is very structurally sound. The biofilms, or slimes and glues, that hold these pieces together have an amazing quality. Like almost any biological slime, like you can think about egg, if it's once it's dry, it's very water resistant. So if you think about trying to wash a plate that had a raw egg on it and you waited too long, it's very, very hard to wash off. The same is true with other slimes you can think of that we might come up with in life. So the soil sponge has two really important qualities that basically make life possible on land. One is that it is water resistant. It does not fall apart when water hits it or when wind hits it. It's very strong. But it's also water accepting because it has all of this space underground. And it's created, as I said, through photosynthesis, plants feeding sugars and carbohydrates to the life underground. So we need to have consistent, diverse plant cover above ground to provide that food source for the workers, these underground workers, to create this sponge. This is infrastructure underground. This is water infrastructure. So we need a food source. We need protection for the workers. Those plants and dead plant litter also provide that protection from heat and also from the compacting effect of rain. And we need a safe climate underground for that workforce. And all of this space actually acts as insulation from the heat or from extreme cold. So we have a good climate, we have good food source, and we have protection. We also need to avoid toxic chemicals that would kill off the workforce. So shifting to forms of land management that don't use biocides, pesticides, etc., allows the workforce to thrive, that can continue to build and repair this workforce. This infrastructure. So those are some of the principles of building the soil sponge, or the soil health principles. So this may look like a funny slide to have here. It's a plate of bread, just wheat flour on a plate. But this is actually the best way to show the difference between degraded soil that has been heavily tilled, right? If you use tillage, you're breaking up that infrastructure that we saw a minute ago. So if you till regularly and you leave the soil bare and you don't have any food source and you don't have a good workforce, the soil will revert back to just those sand, silt, and clay particles, individual, unaggregated, without these spaces in between. So we can use this as a demonstration to show people what happens when we don't have a healthy soil sponge. And the first thing I would usually do is to take this outside and blow on it. And you see that when wind comes along, this kind of degraded soil will become airborne. But also we can show what happens when rain comes. So we'll poke a few holes and it'll make a little cloud. Pour some water in there and see what happens to it. So imagine this is a landscape and that your house is in the middle of it. So you see the water is running off. It's not soaking in. It's taking a lot of the soil with it. So now the rivers and lakes and streams have soil in them, and whatever other chemicals are on the surface. We're creating algae blooms. And as you know, if you've ever baked bread or that kind of thing, if you lift up this film on top, it's completely dry underneath. So all the water is running off. None of it is soaking in for plant growth. We have flooding, very quick flash flooding. And as soon as the water is gone, we have it back to a drought. And if you were to put this out in the sunshine, what happens to this part, this gluey part, is going to form a crust. So the next time it rains, even less water is going to soak in. Really problematic. Also in a hilly landscape, we would have mudslides, right? So lots and lots of different things going on here, that a lot of the problems we have. And if you think about if all of this water is running downstream and eventually reaching the ocean, when we have landscapes that are either bare and degraded or landscapes that are paved over, all of that water that should be filling up the groundwater is moving into the oceans eventually. And we see it's one of the reasons that we have ocean rise. Of course, the melting glaciers is also contributing to that, but people generally don't think about land use as part of the issue with rising global water levels in the oceans. Okay, so what do we need to do to turn flour into bread? We add biology, right? So let's bring in biology, and just like in the soil, when you have biology, you have this structure. You have a new structural integrity and functional integrity. Those little loose particles are now glued together into something that if you blow on it, if the wind blows it's not going to blow away. If the rain falls, something entirely different happens than with the flower. It's soaking in right where it falls. It's going down for the plant roots to continue to grow the plants that are needed to actually regenerate this continually. And you'll see on the other side, we only did 2 cups worth. And generally here we can do like 10 or 15 cups before it even starts to come out of the bottom. And when it does, as you know, because you all work with groundwater, this is entirely different. And if this was like 2 feet deep, you can imagine how long it would take to soak down. And eventually it's refilling the groundwater. It's refilling the wells. And it's also refilling ponds and lakes and streams and rivers, but with clean, clear, filtered water that has been filtered through this big carbon filter. But also it's been detoxified by all of the biology in there. So all of the life in there can take any contaminants and break them back down into just their elemental pieces. Of course, if you have lead or heavy metals, you need a little bit different biology, but that can also be done as long as you're taking away whatever grows in the form of mushrooms or plants that can take up those heavy metals. But here we have clean, clear water that's continually refilling. We have no flooding. We have no drought because this water is now protected from evaporation. It's staying in place. It's refilling the wells. We have no mudslides. We have much more beautiful, clean air because it's not blowing around. And we have a landscape that has the space for plant roots to explore, that has the water and air underground that all of life needs, right? We all need air and water unless you're an anaerobic bacteria, but there are also anaerobic spaces under there for those organisms inside the soil aggregates. And that's actually one of the ways that carbon can get stored in there without reverting back to CO2. But mostly this is a story about water. There's a lot of focus right now on soil carbon, and soil carbon is becoming a market just like other carbon markets. But there's a whole other leg of climate change that people are starting to write about and remember that originally climate was seen as 2 legs. One was atmospheric gases. The other was land use impact on climate. When we started to focus on greenhouse gases, we forgot the fact that this landscape is going to be much, much, much cooler than this one for all kinds of reasons. And if we have time today, I'll go into some of that. If we don't, I invite you all to come on April 12th through 14th. I'm doing a 3-day workshop on this. And we also could get you recordings of those. So we can, I'll make sure that it's affordable for anybody who wants to attend. You can write Mary or write me and we'll work it out. So I would love, love, love to have you all participate in that. It's a live Zoom workshop, 4 hours a day. And we spend a lot of time on all of this. So, but you're getting the first chunk of information here today. So okay, so let's look at what is this. So here's another picture by our colleague Cindy Eretz and my colleague Phil Lee, who took these amazing pictures of the soil sponge. And you can see all these mycorrhizal fungal hyphae underground that are stringing it together, and the sand, silt, and clay clumped into little aggregates. All right, so this is what it looks like more like in reality, right? I have a couple of slides here that are really great. That if you take a clump of healthy soil versus a clump of degraded soil, and you suspend them in a little wire basket or in an onion bag or something like that in water, because of those, remember I was talking about the egg white and the plate, because this has that structural integrity, you could leave this for 24 hours and the water is still going to be clean and clear here. It might fall down to the bottom eventually, but it's not going to break apart. The aggregates actually will hold on to each other, even if you crumble them up. If you put degraded soil in, almost immediately it kind of explodes and dirties the water. And so you may notice that after it rains, a lot of rivers look like this. But occasionally, if you're in the forest or somewhere where there is a lot of life above ground, or a place where people are using cover crops and not too much tillage, not too many pesticides, you'll notice that the streams or water that's coming off of those fields is actually clean and clear. So we have a lot to do with how our water systems look by how we manage the soil. This is another favorite slide of mine. This is called a rainfall simulator that we use here. The USDA Natural Resources Conservation Service and also the soil conservation districts here will go around to farm shows, and there's like a shower head that moves across these. Each one of these is like a big cookie cutter. So it has cut out a intact chunk of soil. And it's open on the bottom with a screen so the water can flow through. And believe it or not, these are all from the same farm. They're all from the same soil type, same ratio of sand, silt, and clay, but they have been managed differently. The jars in the back are collecting the water that soaks in. The jars in the front are collecting the water that runs off. So here, where we have a degraded soil that has been heavily tilled, lots of pesticides, no cover crop, no plant litter left on the surface as protection, and a monoculture, so not using any of the soil health principles. Here, you can see that zero water has soaked in. It's all run off, and it has taken a lot of the soil with it. And this is what we see very typically around farms. As we go to the left, more and more of these soil health principles are put into effect. And when you get all the way over here, you can see all the water has soaked in, nothing has run off. So all of this water is being used for plant growth and to refill the groundwater, potentially even the long-term savings of the aquifer, right? I think of that as our savings account. The groundwater is like our checking account that we draw from. And it's clean and clear, like you and I could drink this water right now without even boiling it, because it's gone through this beautiful natural filter here. So it's essentially, over time that's turning into spring water, which is our favorite water. It's remineralized, etc. Okay, I'm going to stop sharing there for a moment and check in. There is another piece to talk about. There are several other pieces that I might talk about, but I wanted to check in with Mary. I'm not sure how long you were expecting me to present, and also see if there are clarifying questions before we moved on.
I'm sure there are. Ravalji, you're leaning forward. Did you have something to add? You're unmuted right now.
Fantastic, Didi. Thank you.
Thank you.
I'm mesmerized.
Yeah.
You have excellently demonstrated and taken us onto the journey into the soil. But what occupies the soil pore space? You have shown very good number of cavities, vacuoles, space between the interparticulate area. And that is where the whole reaction of microecology happening there. Can you throw some highlight on that pore space ecology?
On the ecology of the pore spaces? Yes. Well, so so first of all, the plant, as I said, the plant is photosynthesizing and it makes sugars, and that's the beginning of the soil food web underground. So the plant uses a lot of those sugars to make its own, yes?
Is it chemosynthesis or photosynthesis? Because some of the pore areas light may not reach at all.
Sorry, can you say that one more time?
It's geosynthesis or chemosynthesis, not photosynthesis. Because
well, I'm talking about the
photosynthesis is photon-dependent chemistry.
Yeah.
Here
Well,
it is geochemistry.
Yes, and I'll get to that. So I'm talking about the beginning of feeding, the beginning food source comes from plants, so comes from photosynthesis, and that feeds around the plant root hair. You will have bacterial colonies that eat those sugars, and you will also have mycorrhizal fungi that are actually inserted into the plant root. I mean, I'm probably a lot of you know this, but not everybody knows exactly the same things. And I'm sure you know things that I don't know as well. So many things. So then there are mycorrhizal fungi, so which are not, they don't produce a mushroom. These are just coming from the plant root and going underground. And they are like an extension of the plant root that goes and finds the minerals and some of the hidden water that is stuck to the inside of those pores to transport back to the plant. So it's a symbiotic relationship. And the mycorrhizal fungi are like a membrane, an intelligent membrane that knows exactly which minerals the plant needs when and in what ratio and what timing and what order, etc. Beautiful, beautiful, intelligent extension of the plant roots. There are some families of plants that don't have mycorrhizal relationships, like the cabbage, broccoli family, etc. But most plants have them. So those are the two initial. I mean, there's none of this is before anything else, right? It's all happening at once. But if we think of it as a flow, there are those bacteria and fungi that are directly feeding from the plant, and then there are all kinds of other organisms that feed on those, right? Including that the plant takes in the bacteria, strips some of the nutrients and spits it back out again. So we have this in and out of the plant and the bacteria as well. In terms of the ecology of all the other life that's happening in the pores, there are, I mean, just almost endless creatures under there that are all eating each other, including earthworms and spiders and things that are making larger tunnels underground. So all of that life is moving through, and that's part of how the pores get created. But as you said, the bacteria and fungi, many of them create enzymes that break down the minerals that make them available both to the plant, but also to each other. So as they eat each other, the minerals become available, right? And then also water becomes available. And this is one of the things we've seen in Andhra Pradesh, is that they are practicing pre-monsoon dry sowing, where they are able to grow crops 365 days a year in some very dry conditions, in part because they've figured out how to stimulate the soil biology with biostimulants so that it wakes it up. And as all of those little creatures start eating each other, the water that is inside their cells is released, right? If I eat an apple, there's no water visible, but as soon as I eat it, water will come out of me, right? So the same is true. If one creature eats another, water starts becoming released. It's not enough water to completely grow a crop, but it's enough water to maybe sprout a seed, etc. And if we have enough plant litter on top and enough plant growth there, and we have that, we start to create a microclimate of cooling and warming, we also will attract the water vapor that's in the air for dew, and that becomes available as an additional source of water. And as I said, if you have mycorrhizal relationships, if you don't till, they can get water that is stuck to the inside of the pore, the way that if you drink a glass of water, there's still little drops in there, but you could put a towel in and get it out. So the mycorrhizae are like that towel. They can get water that is stuck to the inside that would not be available to the plant otherwise. So I haven't fully answered it sounds like you know much more about the geosynthesis, etc., which I would love to learn about. But there's a whole just like above ground, there are all kinds of things, and also we have some bacteria that live on, sulfur or this or that. And there are also some, I've been reading about photosynthetic bacteria, right? So there are a lot of very, very interesting ways of living on this earth that different organisms have evolved. And so, yes, some of them have evolved to live underground in anaerobic conditions, inside the soil aggregate, and some have evolved to live in those pore spaces.
You have answered it perfectly. All right. Thank you
Great.
very much. I'm so glad that somebody, for the first time on this platform, is explaining the sustainable world without using the word water or soil or anything. And in my understanding, membrane is the cellular brain.
I normally would say that I totally agree with you. And I often talk about the layers of intelligence in the world, and that it starts with cellular membrane, deciding what do I keep and what do I let go of, right? What do I keep? What do I keep out? That's the most basic decision we need to make at every level, including in our own homes, right?
But
so it starts with that membrane of mycorrhizal hyphae, the fungi, is the one that is first making that decision for the plants, which affects the health and resilience of everything that eats from the plants, whether it's underground or above ground. And then the animals also have membranes, right, in our gut and in our brains, etc. But yes, carry on.
So what you explained, and I'm in total agreement with that. But that makes me worried, because all conventional agricultural practices with dealing with heavy machineries, they are destroying mycorrhizal fungi. They're hyphae, to be specific.
Yes.
And they are all claiming sustainable tilling and farming. And I am honestly, because if we eliminate mycorrhizal fungi, agriculture is not possible. So how do we, your two slides, one with the flour and the bread, it conveyed the world of sequences happening. So
I think
current, how do you see the current agricultural practices world over?
I think they're creating a planet of deserts, and we have. I mean, the Sahara used to be a fertile land. The Middle East used to be fertile land, right?
Thank you. Salute to you with both my hands.
And I think it's very clear if we say, if you take that bread and you dry it out and you put it in a blender, it's going to go back to being like the flour. And if you add biology to the flour, you actually, in the beginning with some plants, some microbes, etc., you can start to rebuild. So hope is not lost, but we really do need to change fast.
Yes. Didi, Chandra, you just disappeared and went on mute. I hope you're still here. You raised your hand.
Thanks, Mary, for this opportunity. First time I'm hearing technology is appreciating some about. In fact, the word Didi in our language, Hindi, is elder sister. Okay. So, Upendra Ravalji and my sister, Didi's words were so prophetic. They talked about natural science, which will only prevail in the world forever. And we can't imagine something which goes beyond this basic science. Why people don't understand this and implement earnestly in every place possible. The first time, if somebody is getting an appreciation from Upendra Ravalji, I am also feeling very ecstatic about this particular meeting. And in fact, I am in the car, just sitting behind and listening to this. But this is very evolving, practical. The way she demonstrated it, just piece of bread, made my day. This is one of the best ever speeches I have heard in this forum. Thanks to Didi and thanks to Upendra Ravalji for his excellent co-comments. Thank you. We are really blessed with this type of enlightened people. And I wish more such breed of people, not breed of people. Breed of people emerge in every geography possible and make the world a better living place. Thank you, Mary, and your forum and for Altec for giving this great opportunity. We feel very elated and more educated. Rather, I was like a student with awe in my mouth, opened my mouth widely and listening to the way she explained things so beautifully. I wish this presentation could be shown to the children around there in the schools so that they can also understand natural science the best way what Didi could teach. Really very exhilarating and fantastic. Kudos to them. Thank you.
Yes.
Thank you so much.
Mhm.
By the way,
Chandra?
And
for
yes,
all,
I mean, interestingly, we have done this, you know, I came up with this bread and flour demonstration. A friend of mine, Peter Donovan, mentioned, oh, you know, healthy soil is like bread and unhealthy is like flour.
Yeah.
But when I was trying to teach young people, I said, let's do it. Let's try, let's see how it, and every time I do it, I myself learn more because I'm seeing more and more relationships there. And I've done that with 5-year-olds. I've done it on Wall Street. I've done it at the UN. And everybody gets it. Everybody gets it. So I invite you to go home and do it for your family. Do it at the next business meeting you have when they say, how are we going to fix our economy? Do it at the next political meeting when they say, how do we deal with the, you know, farmers, etc. Show people. Yes.
Beautiful. Hari, you had a comment, I think, and then you went on mute. But I think his observation was, go
I
ahead.
just wanted to add after Chandra spoke. Thank you, Mary. To share with all of you that Chandra went on a 30-hour airplane ride to Peru last week for just 3 days of a workshop that he had there or some such that he was invited for. And back again, another 30 hours he must have taken to reach Chennai. Chandra, you want to tell us what you did in Peru before Didi continues with what she wants to share with us all? Chandra?
Yeah. I could not get the question, sir, because the signal is not that good. Can you repeat?
Those 3 days in Peru, what did
Yeah,
you
okay.
achieve?
Yeah, actually, we went to the remotest places in the hilly region. It was mostly below poverty level communities where the gas or the cylinders could not reach out to the top level. So in the place which is a small valley sort of place, they have communities, women, we call us mama. Mamas, there are some 20 or 30 women in a common cooking place, which is well equipped with all the groceries, the food and the material, and the gas supply also. There only everybody come and collect their food because high on the altitude, people cannot even cook food. And all are just tin roof sheet houses, which are really in bad shape. So there may be accidents if at all gas and other things are supplied to the a higher level. So in these type of places, 2 or 3 communities, we were able to give free water purifiers because water was also very bad. And it gave me real sigh of happiness, but also more worry because there the political system is totally unstable. And we wonder how these women could be saved further. So it gives me, when I see the whole valley, there were some more than 40, 50,000 families. We were able to give only for 50 families free this water purifier through a grant I got through Royal Academy of Engineering. In fact, I overspent some 2 to 3 lakhs from my pocket to understand the community and serve them. So this was a very exhilarating experience. In fact, getting vegetarian food was the real challenge. I was only surviving like a goat for almost 7 days, only eating vegetables and fruits. And in spite of that, I enjoyed the best moment there when I saw the smile on the faces of these women. They all gave me a good hug. That was worth a million crores of money rather than getting the water purifiers paid by them. So this was a very great opportunity. I wish I do more of such experiments and lifetime experiences in the days to come. Thank you, Hariharanji, for asking me. Thank you.
Thanks so much.
Yeah.
Over to you. Yes.
Yes. So Didi, in answer, what we do with these programs is have you present for 30 to 45 minutes, and then the group engages and tries to figure out ways to expand your impact potentially with organizations they may know that they could share this information with, or with other applications. And so I invite all of you who are listening to think about ways or places that Didi's information could be connected, and maybe place it in the chat or plan to share. And you can continue, Didi, but there is one question, just the role of your ecology in the soil pH. It's obviously impacting the soil pH. If you could speak to that.
Yes, I'm not really the right person to speak to that. My work is mostly in sort of like the bigger system, like how it all works together. And many of the details, there are people who are much better to speak to that. My sense is that it would probably tend to regulate, because whenever we have a very, so if it's very acid, it would tend to be more neutral. If it's very neutral, it would tend to be more acid, because that's how life tends to work, is that the more diverse biological systems are working together, they tend to self-regulate. So, but I don't have a very specific answer to that.
Yeah, Hari, did you want to comment on that?
Sorry, no, not comment. We will listen to her.
Great.
The second part of what she wanted to present.
Yes, thanks for checking in. I'll monitor the chat and let you know if there are other questions that come up. Thanks, Didi.
Great. Okay, so for this part, because I don't know if those who just joined, we're in the middle of a power outage, so I'm in a kind of a special circumstance here. So I don't have everything here that I normally would have to present, but I do want to talk. Very, very key other piece here is what I call the biotic climate cycle, or the biotic water cycle, as opposed to what we might call the antibiotic climate cycle. And this is about how the work of other species actually creates rain, creates gentle weather and gentle climates, and gentle temperatures, et cetera, and regulates itself. So like we were just saying about the pH, temperature tends to be regulated when you have diverse vegetation, diverse animal and fungal and bacterial communities, and a deep soil sponge. So one way that it's regulated is that it's regulated underground, as I was saying, that having that pore space underground actually acts as a layer of insulation. And so that's regulating the climate underground in terms of temperature. It's slower to freeze and it's slower to warm up. I highly, highly recommend that you get, I don't know what they're called in India, but it's like a thermometer, a digital thermometer that you can point and shoot, and it's got a laser and it measures the temperature wherever you're pointing it. You could even point it at the sky and see that it's, -20 or something like that. And what we are seeing is that the ground temperature difference at the surface, when you have either pavement or bare soil or grass, or not just grass, but or plants, let's say, that temperature at the surface can be, and I'm sorry, I tend to think in Fahrenheit here, but it could be 40 degrees Fahrenheit difference, which I believe is like, 20 degrees Celsius difference, a huge, huge difference. And we know this from children, right? Most of all of this we've learned from childhood. We know that if we were barefoot and we step on a black pavement or brown soil or green grass, we know what to do to keep our feet cool, right? So we know that the surface temperature is very different between those three. And part of that has to do with the soil sponge underground regulating the temperature. And part of it has to do with the place where there's vegetation, that the surface is being shaded by the vegetation. But there's another factor that's really key and that actually could potentially cool our entire climate, and that is plant transpiration. evapotranspiration through plants. Plant evapotranspiration is basically plants sweating, like the water is evaporating from their leaves, from the stomata of the leaves. And when water changes phase, so it evaporates from liquid water to water vapor, which is invisible gas in the air, it uses heat to do that reaction. And the heat changes from sensible heat that we can feel and that is heating the surface of the leaf, of the ground, etc., to latent heat, which we can no longer feel, is no longer heating anything because it's being used in that reaction, that evaporating reaction. So as we know, when we are sweating, having sweat, especially if we put a little wind, which speeds up the evaporation, will cool the surface. And it's not just cooling the surface, it's also cooling the air around it. And so this is how air conditioning systems work, right? They are evaporative cooling systems. So the air around a plant that is evaporating is much, much cooler. So they say that, for example, a typical tree, when it is transpiring, is actually cooling the air around it equivalent to 2 full-time air conditioners running all the time. And that's not about the shade. The shade also helps to protect us from the heat of the sun. But this is actually, the air is literally cooler. It's not just that we're protected from the sun. It's that the heat is no longer there. It is bound up in that water vapor. So that's with a tree, but if you have a whole landscape that has diverse plants growing, you will notice that it is also much cooler. Even if, and the place I felt this most strongly was when I was in India, in Andhra Pradesh, and we were working under a tent that was in the shade, and it was still very, 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 very hot. And we stepped out from that tent into a shoulder-high, diverse cover crop. And even though our bodies were exposed to the sun, it was much, much cooler. So there's a study from Turkey that I'll have to try to bring up somewhere so I can get you the exact numbers. But there's a study from Turkey that shows that for if you go from like pavement, from a diverse vegetated landscape to pavement, it's like, I think, 12 degrees Celsius cooler on the vegetated landscape, the air above that. And if you go from vegetated landscape to bare soil, it's about 7 degrees Celsius cooler. So my colleague Walter Jena, and also my colleague John Norman, who basically literally wrote the textbook on environmental biophysics, they have calculated that in order to reverse the global warming that we have already seen, we could do that globally by increasing plant transpiration by 10%. But we don't necessarily have agency over all land, right? So they looked at just agricultural land. 40% increase in transpiration on agricultural land could, in theory, reverse the global warming we've already seen simply through that latent heat flux that I was describing. Of course, there are other factors, but many of those other factors are working in our favor, not against us. Because in order to create the conditions for that much more evapotranspiration, that means we need more cover crops. It means we need more diverse cover crops. It means that grazing systems, we have to leave the grass longer. And of course, we're only talking agricultural systems. What if we include in like the global north, in the US, et cetera, and in cities in Delhi, what if we include the lawns? you know, here in the United States, we have laws that say you have to cut your lawn to only be short, right? But what if we were allowed to double the height of the grass that's growing? That's 100% increase in transpiration. And that 40% increase overall was not including lawns. It's only talking about agriculture. So this is actually something that we can do. And if we have diverse vegetation, if we have more photosynthesis happening, as we talked about before, that's providing more food for that underground workforce to build a deeper soil sponge, to hold more water, which allows transpiration to happen more easily. And transpiration is that cooling effect. So the other way we can do it is simply by building more of a soil sponge in places like Andhra Pradesh, where we typically have a kind of a brown or red carpet season and a green carpet season. We can extend the green growing season. We can do that in places where there are grazing animals. We can do that in places where we're growing crops. And let's see if I can find this very amazing video from Andhra Pradesh. Let's see, might take me a minute. So in Andhra Pradesh, like I said, they are now successfully having a like 365-day green cover in many areas. And that has huge potential for cooling. So here is a woman named Parvati, her farm. Let's see if we can get this going. It's a drone footage here. So look at the diversity of vegetation. All of that leaf area allows for more and more transpiration to happen, more and more cooling of the air. So I like to think if I was a bird or an insect looking for a nice, cool, moist place to land, where would I go? And if I was underground, where would I like to live? Right? It's very, when we see that, it's like, of course you want to stand there. It's, of course, that's going to be cooler. And they've done this using natural farming, using all kinds of natural things, no biocides, using lots of diverse vegetation, managing insects through agroecological principles, using no nitrogen fertilizers. They've doubled or tripled their net income because they're saving money by not using all of these kind of green revolution practices. And they're actually deepening the soil sponge and providing local cooling. Okay, so really key thing here now. By providing that local cooling, you create something called a low pressure zone that's like sucking air in. If we can go from the coast to inland and have diverse vegetation across the continent, or even just a corridor, kind of like we have a wildlife corridor, we actually create a suction that brings the moist air from the oceans across the continent and allows for rain to fall more evenly. We have less big storms on the coast. We have more rain across. We also have cool air that can keep bringing that cool air over from the oceans. So clouds form over the oceans, but clouds also will form over diverse vegetation, particularly old growth forests. Very, very, very important to protect our forests, our diverse forests. But also over diverse vegetation, we see it, right? We see the mists come up in the morning if we have a nice, if you go up to the hill country or something like that. So, but then, so there's the cloud, right, forming, because the water will condense onto these volatile organic compounds, onto pollen, onto various things that are in the air. It will also condense onto exhaust fumes, right? Diesel fumes and et cetera, that's hanging in the air. And there we get the humid hazes that we see over big cities, that you can hardly see the sun. It's like the air is brown, it's hard to breathe, right? It will condense onto little smoke particles from crop burning. That holds the heat in. But when it condenses into natural organic compounds, et cetera, that the plants produce, it creates those big fluffy clouds like I was showing a moment ago. Those big fluffy clouds, though, it still has a lot of water in it. How do we get it down to the ground as rain again? It's the biology in the system. There are bacteria in the air, in the clouds, that are the only way to get that water back down to earth. They're the only thing that can condense enough water around them to have it fall as rain or snow or sleet. Over the oceans, it's biology that's produced by the plankton. Or in the high altitudes, it's biology that produces ice crystals. Over forests and temperate areas, it's microbes that are produced, that live in the stoma of trees and that go up with the transpiration stream. But again, this can't happen on land without a soil sponge and without diverse vegetation. Those clouds also provide that albedo, they provide that shade, right? Shade, sun, shade, sun. So you put a sweater on when it's coming, when the cloud is there, you take it off when it's gone. If it's just a haze, it doesn't have that effect.
Yeah. I noticed a question from Ravalji, who
Yes.
needs to lead.
You have very well explained the vaporization and all that. I have been trying to look for the answer that the ocean water is H2O, but the isotope of oxygen is 18, O18, 18. And when it evaporizes, vapor is also H2O, but the oxygen isotope is 16, O16. And when it comes back and runs on the surface of the soil all along, the journey that you have explained, that isotope change brings in something that, of course, the chemistry says isotopes cannot change the property of the atom or molecule. But here, I'm inclined to differ with that statement, because the rain drop is H2O16. As it travels and meets the underground streams, it becomes O18. H2O, the chemical formula is H2O only, but it is the oxygen isotope becomes heavier. 18 is a heavier isotope.
So are you familiar with the work of Gerald Pollack? The fourth phase of water?
I'm trying to understand and unable to recall offhand, but I'm just trying to go deeper if you can.
I think it's a very interesting question. And what we're seeing at University of Washington, there's a scientist named Gerald Pollack who is studying water in living systems. And a living system could be a body, but it could also be the whole living system like we're describing, right? And when it is in those systems, it becomes organized in ways that are not what we expect. And it explains how water can travel so far up to the very top of a tree against gravity. It explains how water can sit through a capillary that should not be able to go through because the pump is not as strong once it gets into the capillary of a system. But water takes on qualities that actually is self-organizing and helps it to move and helps it to have a different phase, basically, when it is in contact with a living membrane. So we're back to the membranes. This gives me chills just to talk about it. So you're right. You're absolutely right. There's something going on that is worthy of study, but I keep going back to we don't. It's great to do the research, and to explain all of the very, very intricate science, but we know everything we need to know. We knew it as children. We knew it that standing on mud is cooler than standing on dry soil. We know that standing on grass is cooler than standing on bare soil. We know that standing next to a tree is cooler than standing just in a bare pavement. So we know what we need to do to implement this. Of course, there's lots of things still to figure out, lots of interesting questions and research, etc. But we know how to make rain. We know how to cool a city. We know how to cool a rural area. We know how nature grows food. All we have to do is look. Nature always has diversity, never grows a monocrop. Nature always covers her soils. Nature always includes animals in the system.
Mhm.
Nature always has some dead plants on the surface as well, some dead leaves for protection. Nature does not go through with a huge machine and break everything up. Sure, yeah, squirrel may go and make a nice hole that when the rain comes, you have a little priming of the system, but does not destroy the whole landscape. So we know what we need to know. We just have to observe how it happens in nature and start applying that to our farming and our cities, etc. Yes.
Lovely, lovely, marvelous.
Wow.
Thank you.
This is truly amazing. We haven't heard, and I'm sure everyone here will endorse this. We haven't heard anyone explain this as lucidly and as potentially as easily possible and feasible for humankind.
Well, and Hari, given how easy it was for all of us to immediately see the bread, to see the flow through, why don't we do this in all classrooms? I mean, Didi, I guess you see how people get it right away, but we have been blinded and convinced by fertilizer companies and by, big agriculture that we should have these massive systems that grow corn, 1,000 acres at a time. In fact, a person came on this talk and shared the efficiency of fertilizing or watering a crop of that size and was basically laughed out of this group because of the diversity needs that everyone here is aware of. So how do we scale your stuff? Or Hari, maybe Didi, you could comment besides just.
Mary, I'm fully with you on what you said of the first deck that she showed us, for example, in a way that we are able to take it to these 4,000 plus children. Vijay Kanda is listening. We will see how we can take that part of the video and get the children to relate to it. We'll see how we can experiment on that once the academic session starts here in India in the schools that we're working in. Didi, you saw that quick presentation Mary put up in the beginning on what RainReach is doing. So we have a wonderful platform today of nearly 5,000 kids, I'd say, between age 9 and 15. And we want to see how we can take it, to more schools, but that's another story. So Mary, we will do that. The other is that toward the last 10 minutes, the way she explained how nature works. Didi, my question to you is, in just the ways you showed us how sponge works with bread and flour, can you also get somebody in your team to graphically illustrate what you spoke as spontaneously on nature's behavior? That will help enormously children.
Yes. Normally I would have a whiteboard going where I actually draw that. And that's also where I'm about to give you a link to an article that actually has the whole thing in very short form. Let me put that link in here.
Great.
Uh, so, and I agree, though, I think that creating some videos, etc., but also literally just having students go out barefoot or with their hands to feel the different temperatures. And then if you have the money to have the measurement, to have that thermometer, to measure the different temperatures, and there are lots of things which the manual that is already existing that Mary posted, and then the new one that's coming out from FAO, they're both free. And they both are like lots and lots of exercises you can do to experience this with your body, or to just even remember that you already know it because you have done it as a child,
Yeah.
right? So this link here on Substack that I just posted is an article that summarizes everything that I've talked about today.
Wow,
And
great.
And you can
beautiful.
subscribe to that Substack, the Wisdom Underground Substack. And there are interviews, there will be more articles. I'm about to post one about the financialization of nature and what can go wrong there. And why we need to just have a very critical thinking before we sign on to, I see people are signing up already. Thank you. But before we just sign on to a carbon market or something else, that in terms of food and water and land sovereignty, be very cautious about anything that middleman is going to make a lot of money by you managing land a certain way,
Didi, sorry to interrupt. I think you are in Hyderabad right now.
No, actually, I'm in the United States in Vermont.
Okay. But somebody in the text box, chat box, they said are doing some project in India, Andhra Pradesh. So I was wondering whether,
Yes, that is Andhra Pradesh Community Managed Natural Farming, and most of their videos are on Twitter.
Chandra, she was here some years ago, not now. She was
I was there in 2019. Yeah, I was there in 2019.
Okay, got it. Okay, thank you.
Good evening, ma'am.
Yeah.
Yes. Hello.
You're able to hear me clearly, or okay?
Yes.
Yeah. Thanks, Didi, for the lovely, beautiful nature-based talk. In fact, I believe that soil is a living being, and you explained it so beautifully. And my work has been basically feeding the Mother Earth with the rainwater. The soil acting as a sponge. The city dwellers, we have made sure that the soil doesn't act like a sponge, by which we have got flooded roads and thirsty summers.
Yes.
And killing the soil for generations to be there. So, and if you take the physical property of the soil, 1 unit, 50% is solid soil, 25% is water molecules, and another 25% is the voids or the air. So in case structurally we don't give water to the soil, soil dies. So this is...
Sorry, the last part that you just said?
You're able to hear, or should I wear the ear?
I just missed one sentence.
Yeah, that is, if you take the physical structure of the soil as an engineering student, the solid soil particles are 50%. Roughly 25% is water particles. And another 25% is the voids or the air.
Yes.
And the organic molecules attract more water.
Yes.
So my work, the city dwellers, what we have done, we have made sure rainwater doesn't go to the soil. By which all problems have started. Like floods roads flooding during the rain and thirsty summers.
Yes.
So my work has been do simple measures for allowing rainwater to go into the ground. This is what I've been working for. So I thanks a lot. I thank you for highlighting on the animal or the we have got much more living species within the soil than above
Yes.
the soil. Yeah. Thank you.
Wonderful. Thank you for your work. It's very important. Yes. And
Yeah,
it's just so important to understand that getting the water to soak in, we can do with a pond, etc. Right? There are some structural, physical ways we can do that.
I think,
But really keeping it going, we really need the plants.
no, allowing the rainwater to percolate into the soil the most natural way.
Yes.
Yes.
And one
Minimum.
second, because I need to plug in a different plug. I'll be right back.
okay. Wow, yeah,
Mary, Mary, excellent. You brought this session,
it's so, well,
which is so educative. Thank you very much.
I think Mary, Ravalji has become 20 years younger today by listening to this. I feel he is nourished more than the soil. I think our Ravalji is nourished very much today. And I'm so happy to see his happy face. First time he has been given accolades to the speaker rather than commenting or criticizing there. But obviously, because he is right in his own way. But I'm seeing such a happy face. By saying that, I am feeling so happy actually.
Yeah, but Didi has said so much about soil without using the term clay.
Agreed, sir. Agreed, sir. Yeah.
And the clay is a galaxy by itself.
Correct.
I
Agreed.
think, Chandra, I would like to tell Ravalji has recently attended my talk and he has been appreciative so beautifully with smile.
Yeah, I agree, sir. So one person who understands science perfectly. That's why I keep calling him Bhishma Pitama in our industry.
Perfect understanding is a very distant terminology. Anyway, but I want to register with Dr. Hari that whatever Ramkumarji, whatever presentation he made, we should take it up on this platform as well. Thank you.
mhm.
Didi, I have a confession to make. And then after that, I have an announcement to make, which I shared just now with Mary. The confession is this, that there are a few times, I won't say several times, when we have invited a speaker and we have found, much to our dismay, that the person is simply not anywhere at the edge of comprehension of the kind that you showed today. That's one of the reasons why Ravalji is.
Dr. Hari's voice is slightly
kept up
lower.
Yeah, can you speak up a little bit more, Hari, or closer to the?
Okay.
Yeah.
I'm actually joining from another device because I forgot. Of course, I can't plug into the wall. So hang on one second here.
Okay. Maybe
But I
you
want
can
to hear
me
what
now.
you're saying.
Yeah, better now.
Yeah. So all I was saying is, and I will quickly say that we don't get speakers of the kind of timber that you represent, Didi. Often, ask Mary and she will tell you offline. We've had challenges of that kind, and when we have people like Dr. Raval who can't suffer unintelligence, it becomes a challenge for all of us, right? That's one. The second, the announcement I want to make is that to all of you here who are regular forum members, that beginning this year, before December, before the turn of this year, we will publish a book, which will be a set of maybe excerpts or transcripts that we take from each of these stellar speakers. Put them in a way that each of these chapters will be about 3,000 words. And so we will have about 20 speakers and a book of 200 pages. Any thoughts on this, Mary first, and then the others? And you know the kind of speakers we've had. We can choose from the 155 or 156 speakers that we've had so far. Didi, that's the other thing I want to tell you, that in the last 3 years, we would have had about 158 weeks, and we have had 156 presentations. That's nearly one a week, right? And so, Mary, your thoughts on that, please, first.
Oh, I think we actually had an idea of this 10 drops of interest for waves of impact, but maybe it's 50 drops of interest for, a tsunami of impact. But I think Greg Greg Chick, and you'll remember Malcolm Fabii, who used the microbiome. He's someone I should introduce you to, Didi. And also Adam Tank, who is doing now Organica, and he had he has just introduced a new book too. But I would agree that Didi brings it all together, and most importantly, for understanding the total ecosystem. And it would be nice if the solution providers you identify, Hari, are mapped according to like the rainwater, the lakes. I also think the lake restoration effort through nature-based solutions is very exciting, but I'll turn it back.
Lovely.
Didi, maybe you could share who are your favorite speakers on this topic.
Well, Walter Jena, who I've worked, we've spoken together many times, and a lot of what I now talk about, the biotic climate, used to be his portion of how we spoke together. But since COVID, we have not been able to travel together because he's based in Australia. So he's wonderful if it's possible to get him. I know he's dealing with some other challenges right now. I think there are a lot of people that can speak well to aspects of this. And I'll try to put together a list for you. I do think that if you could get Gerald Pollack, that would be fascinating to speak to the, how water acts in living systems. It's different than when it's just in a pot or in a pit of sand or something like that. He's very engaging, and my colleague Peter Donovan is at the Soil Carbon Coalition, is also someone who likes to think in big systems, and he has been very involved in the idea of like, how do we create community monitoring and mapping systems. So he has an app called soilhealth.app where you can monitor things, but he's very much of a philosopher.
Didi,
but I'll think about who else. Go ahead, Hari.
Talking of big systems thinking, one of the things that has been sort of agitating my mind is this challenge of telling decision makers, whether they're in the government or in industry. We know the levels of ignorance or of, of whatever, of comprehension. Sometimes I think it's very deliberate. They understand it, and yet they do the kind of things that they do wantonly, right? How do we take this challenge of big system thinking, let's call it now, to industry leaders is part of my agenda for this year. And I have somehow managed to get about 10 people enrolled into the idea, if not the vision of it, right? Dr. Raval, for example, here always is scoffing at me and a few others on how, and very well-meaningly, on how industry simply doesn't want to do anything, And he has had some difficult experiences with industry leaders. They listen to him, spend an hour or two, and after that, they do nothing, So if we are taking up this kind of BST, big system thinking, it occurs to me that I can keep this communication going with you and ensure that we draw you into some such conversation, which will essentially center around pushing the envelope of thinking in industry and in government. Your thoughts, please.
Yeah, this is something that I think about a lot. And as I said, I just presented with the Alliance for Food Sovereignty in Africa. We had a policy seminar, and I had a brief amount of time to present about all of the ideas that are out there right now that are saying we can only save nature by financializing it, by monetizing it, and also sort of the public-private partnership issue, et cetera. And I think it's possible that some good things may come out of that, but I also think it's a very dangerous game to think that we have to monetize something in order to preserve its value. So to me, there is a paradigm shift that is needed. And it starts with ourselves watching our own language and our own way of thinking about things. And I think it's an ongoing process of education in community, so in circles, in relationships, to keep that paradigm shift alive. It's very hard to stay honest, and that's why I love that you're meeting regularly. And I have a weekly group as well, that if you take that course, you can then come into you've gotten a lot of the information that you would need to understand what we're doing in that weekly group. So let me know if you're interested in joining the weekly conversation.
Which day is it, and at what time, your local time?
So we have one week, it's on at about this time. On would be my Thursday, which I think is still your Thursday. Yeah, you're 11 hours ahead.
That's right.
I think
that's right.
And then the other week it's in the evening, so it would be like my 5:30 would be your 4:30 in the morning, so not so good.
And both are on Thursdays.
No, one is my evening one is Wednesdays.
Okay, that's right. I got
morning
that.
one is Thursday. So
okay.
Yeah.
The other is on the April 12 to 14 workshop. Sorry, you wanted to say something.
Yes, the April 12th to 14 workshop is from this hour for 4 hours. So from starting now in the day to 4 hours from now for 3 days in a row.
So, Mary,
so it might be not ideal, but it's possible. So
once she's got the invite out, Mary, we can send it out to the entire group here and hope that there will be people who will want to engage.
Yes, that would be great. And it's also recorded, but it's very much of a dialogue. So being there live is great if you can be there live.
You see, Mary spoke about scale, and this is something that engages all of us, I think, hell to be speaking. We need to see how things like the stuff of the kind that you do can go on some basis onto the web, and people participate in those without you having to be doing it as a real-time online. It has to be an anytime online, if that's possible. I don't think that there are any digital people here. I'm seeing Nikki here, but there's no one else who comes. We are all of the analog age in that sense. So I'd like to see if we can, find someone like that who can do an anytime online of the numbers of things that you already have, sort of archived.
Yes, we can definitely work on that. And one of the places where I get hung up is in like tech support, and I know that that in India there's amazing tech people available. So that's something that if there was someone to connect me to who can help to edit some videos and post them and get them out, etc., that would be wonderful. Because I'm a one-woman show here, so
Well, and
I wanted to just.
Oh, go ahead. I just wanted to acknowledge Cindy Ehrlitz is in our community, and she is out of Australia working on sharing your information, Didi, or promoting your stuff. So she could be a good curator. She's putting together a list of top 10 reads to get people up to speed on all of this, but big fan. So sorry about that.
Yeah, Cindy's a good friend. So we both.
Yes, sorry, Didi. Mary, you and I need to speak on this maybe sometime, or even exchange some WhatsApps or mails.
Yeah.
See, a lot of what Dr. Raval has been speaking of the last, say, 3 years needs to get documented, but, in a way that people read or it impacts tangibly. This is one. I would say the same of, say, Didi's work. So these are people who are analog, clearly, like I am. You are in some way. You're much better than the rest of us. And we need to see how we put this out in ways that it's visible too. Nikki, you want to speak on this since you're here? Nikki?
No, I'm here. No, I mean, definitely. See, a lot of it has already been recorded from many of these conversations from WoW and things like that. What is missing is some form of transforming it visually that makes it more engaging to more people. It's just mostly it's a talking head kind of thing, right? Well, a lot of things that what Didi spoke about lends itself very nice to some sort of basic animation that we can pull out from AI and things like that just now.
Hmm.
It needs a little more thought and some more conversations offline. But yeah, I'm willing to be part of this conversation with Mary and you, and so we can see how we can take the top 10, say, of things that that have happened from WoW, and including today's conversation, and then see how some snippets of it we can kind of animate or do something that can make it.
That's the tech side of it. The outreach side of it is, I think, something that should concern us more. We don't want a Mona Lisa, really, Nikki. We need something that goes out there to 100,000 people. And that's not even audacious. We are just an ambition.
For instance, I got that, but for instance, that little Better India thing that Mary kind of shared in the beginning of this thing has reached almost 40,000 people in 2 days.
Yes,
and it's got at least 2,500 shares, and that's because of a form of Better India, right? And so I mean we can collaborate with such people who have such great social media presence and figure how we can put this out there. That requires again something that's a much longer conversation that has to be offline from what we are currently speaking here.
Got it. So we need a Better India format. Mary, anything on this? You see, it doesn't make.
I don't think we need a Better India. Sorry. I don't think we need a Better India format. But we need collaborations with people like Better India.
Right, influencers. We need to connect with these large internet influencers. I think there are a bunch of mommy bloggers we use in the United States. Moms want to share this type of stuff, Didi, and we. So I think we'll do an offline conversation. Hari and Nikki, I totally agree. And Ram Kumar has a great thought leadership to add. Ravalji does, and many of you on this call. If you want to, if anyone wants to just add resources that you'd suggest be included in this to the chat, or contact Hari on that. I just, I mean, we're at time, and Didi's working on a generator on borrowed time, borrowed energy, and we're just so grateful this worked out. So we appreciate everyone who was here, and I just want to honor time. Didi, did you have any final comments or thoughts? And
well, just speaking to that last question about the paradigm shift, what's needed for industry, et cetera, and political systems to shift, I'd like to just share a framework that Carol Sanford, who I work with, uses a lot. And to think about this for yourself. This is never to be used as a weapon to critique someone else. It's to help uplift our own thinking. And the lowest paradigm that we all fall into sometimes is, how do I get more value than what I'm putting in? How do I return value or extract value from this living system? Whether it's, is my son going to take care of me when I'm old, or can I get a better view by cutting those trees? Or the next one, when a lot of us are in that extract value mindset too much of the time, we end up with so many problems like we have. And then we end up all the time worrying about, how do I stop bad things from happening? How do I stop disorder? So we end up with, fighting against this corporation or that one, or we end up with wars over resources, or how do I stop tillage, or how do I stop the worm from eating my tomatoes, right? So we end up always in a war about something. The third one, when you have those two going all the time, then you end up with a lot of poor people, etc. And then we get into the do good paradigm. I'm going to donate to this charity. I'm going to set up a food shelf. I'm going to create housing for the poor, etc., which is all nice and good. But a lot of the money for those projects comes from the extract value Wall Street corporate economy, and it becomes a tax haven, right? So it's like you're still going around in circles because the nonprofit is drawing on the money from the wealthy. So we need to shift more and more and more of our time and our thinking into a new paradigm, which is how do I grow the capability of my community? How do I grow the capability of the landscape to soak up water and everything is fixed all by itself? We don't have to figure out how to suck CO2 out of the atmosphere. We can just go make plants that do that naturally. We don't have to drill millions of wells. Maybe we do short term, but long term, we create a soil sponge that is a well in the whole earth. So we have to think about how do we regenerate living systems? How do we grow the capability? And how do we do it in a way that is very unique to the place we are in? It's not a one size fits all. It's not a BMP, best management practices. It's principles that are universal, but it's practices that are unique. We know our own community. We know ourselves. We know this place. We know how to make it more of itself, how to celebrate what's already here. Okay. That's where I wanted to end.
Beautiful, beautiful. Ravalji?
Didi used a term, albedo. And I humbly submit to this platform that with all its software technology, if Bangalore can produce the albedo picture of Bangalore for last 5 decades, and that will explain everything that Bangalore is going through today. Albedo is just one term, but it's again a deep sea within itself.
Oh.
So we have to pick up every pearl that she has dropped today and learn on from there. Otherwise, software technology it's only piling up the data.
Absolutely.
If not used for general good. I'm so deeply grateful to her. Not even once she said millions of dollars and billions of dollars and all that. Try to see this. All our talks of advanced technology is emphasizing on the budgetary escalation. That's frustrating. I just want to tell you, Didi, one humble submission. Survival of the fittest was not what Darwin wanted to advocate. The purity of gametes was hijacked by the dominance of economics. The missionaries who funded the project wanted him to complete the book. He was not well in his last days, and he had to submit it like that. But what he wanted to really write a book was, it is the survival of those who are willing to change. Otherwise, dinosaurs were the fittest.
Yeah, very
and
quickly.
Today, Hariji, my personal submission to you. As an economist, you think money rules the world? No, sir. She has thrown that out of the window today.
So, agree with you. Arun, do you have anything to add? Arun Kumar Sridharan, would you want to share your take on what Didi presented today? Arun? No.
Yes, thank you, Hariji. I really appreciated the speakers today. I really would like to echo the comments regarding how there is no one size solution that fits all, that we need to sort of, although we are in a corporate heavy environment, we need to all think more broadly and try to find solutions that fit different ecosystems, and really look at it from a holistic point of view, right? How we increase our own capabilities of the communities to be more resilient, increase the capacities. And this is something that we also learned from COVID, right? How do we increase the resiliency of individual people or families. And I think the solution lies in really thinking much more broadly than the science itself, right? How do we structure our societies so that with an emphasis on sustainability, right? And I think the solutions that will come out will be very different than purely technology-oriented solutions, right?
Absolutely.
Yeah, that's why.
Yeah.
Really appreciate all the speakers, and I hope to reach out to the speakers offline and connect.
Thank you. For
Appreciate the
joining us.
links that were shared in the chat box as well.
Yes, and you could happily connect with Didi too if there is anything that you can pick from her or offer her. Festus Langat, would you want to speak?
Yes, sir. You bowled so many googlies. You have to catch up. So
Okay,
you asked
Chandra.
one thing.
Chandra, just wait one
Yeah.
second. Festus from Africa is joining us. He's from
Yeah.
Kenya.
Yes, Festus.
Yes.
Good afternoon.
Yes, I would like. Good afternoon, sir.
Hi,
Thank you very
Festus.
much.
Good to see you.
Hi, Didi. Yeah, good to see you. Very wonderful presentation. I would like to really thank you for the very beautiful presentation. And actually, I've learned a lot. The very beautiful, simple, and very educative. I will shall apply the knowledge that I acquired today. Actually, what we really want to heal is the soil so that we can get more production. And I really acquired very, very important information to that effect. Thank you very much, Didi. And thank
Which
you very much
country?
for all the
Which
speakers.
country are you from, Festus?
Yeah, I'm coming from Kenya.
Kenya. Okay.
Kenya.
Because
Yes.
we all very carelessly say Africa. You know, it makes no sense. It's like my being told that I'm from Asia. It means nothing to me, right?
Yeah.
Sorry about
Yeah,
that.
sure. Yes, yes,
Right?
yes.
Yeah. You are 54
Yes.
countries. You are not Africa. You are
Yeah,
one
we are not,
country there.
we are not African.
And you're
Yes, we are not
multiple.
African.
You are hundreds of races and communities of that kind. Wonderful. Over to you, Mary. Yeah.
Oh, Festus is implementing a rain reach program here with the help of Greg Chick very soon. So, and
wonderful. Yeah, yes,
so,
yes.
and Didi, I know you may have to hop because you're short on, and we've gone over time. Okay.
Yes.
I'm okay. I'm okay. I'm on the new computer. I have two computers, so this one has a battery.
Yeah,
Okay, I see just a few more comments and then
Apurva wants to speak, but before that, Chandra, can you finish what you wanted to say quickly, Chandra? And then
Yeah,
Apurva.
yes, sir.
Yes,
So you talked about the book. What
Yes.
I can contribute is time, which is very precious for completely proofreading the whole thing and doing illustrations for the cover and individual illustrations.
Oh, lovely.
And an artist, basically, I would love to do that for you, sir.
Oh, grateful to you. Thank you so much, Chandra.
Thank you, sir.
so much.
Thank you.
Apurva, please.
Yeah, sir, what I draw or learn from all this, see why engineering is separated with biology. See, engineering, the fundamental problem we created by making sure that engineers don't learn biology. Right now, all the problem now, what solution we are getting is fundamentally because biological side is ignored by, or ecology is ignored, or nature is not understood by the engineers or policy makers or decision makers. So it is up to us now how we can inculcate this into the curriculum, whereby these fundamentals or principles are understood and then practiced.
Got it. Subhash, you want to say something?
And sir, organizations like even IGBC, BIS, or all IFMO and all codal standards have nothing like this in their codes. So we have to make sure that
we are working on it. We'll work on it. We'll not give up easily, Apurva. We'll work on this.
I am in your team, so you can trust me. Yeah.
Indeed.
Thank you.
Indeed. Thank you. Senthil, do you want to add anything? Senthil Kumar is from Chennai. Senthil Kumar? No. Okay. Yes,
Subhash, I thought Subhash.
Yes, Subhash Reddy. You want to say something? I know you're listening to it quietly. Subhash? No, we are missing him. I think it's sometimes, network shut. Well, over to you, Mary. I think we should close out of deference to Didi's time and the energy that she is literally, physically running out of. The world will run out of it soon. but that's another day.
Yeah, but she has also energized us.
Yeah,
And so
totally.
we just thank you so much, Didi, for these
Totally.
integrating these concepts, which are, as you said, nature we knew from the beginning, but it's been sort of hidden and camouflaged by this commercial interest that the world has sort of inserted us into, when that's not what's most important. What's most important is relationships and whole health, and allowing for nature to do its thing. I want to, we all want to continue these conversations, obviously, and see how we can return to a Garden of Eden with the transpiration and with the holistic systems working. And so we are all for what you're doing. We'll spread your knowledge everywhere. I think you've heard a commitment here. And I said, Hari and I are going to hook up and we'll be back in touch, but know that you have a whole support structure here ready to share your examples out to India. And Hari, I'm sure we'll have you on the speaker circuit across India.
Yes, I will.
That's
soon enough.
fantastic to connect with all of you. I'm very inspired to hear all of your thinking and your comments, and to hear about all of the work that you're already doing there. That's fantastic, and that is helping to create the conditions for the sponge to grow. And, you know, first we need plants and first we need water. We need both at the same time, you know, and then one follows the other.
Can I last sentence?
Okay.
From this session, it came to my mind that Michael Seth, an Israel author, wrote a book, Let There Be Water. That's the title. The booklet that Vogue proposes to publish, the title should be Let There Be Soil.
Wow. Great. We'll look at it. I'm into that. Over to you, Mary.
Yeah, well, when we'll continue these conversations also in globalwaterworks.org.